Okay, good morning, yes, college student. I'm very pleased to welcome you here in this morning in the seminar or general courses. Okay, good morning, yes, college student. We will have two lectures this morning. As you know that computing system are around us. It's not only as a abstract software or as a isolated hardware. It become deeply embedded in our physical around us. So it controls a very critical system, healthcare system, identification system. So the verification, the security, the functional is very important. And today we will have two lectures, about that uh, that that problem, the problem of computation around us, about the functionality, correctness, about the safety, and about the security. And our first guest, we will honor to have Professor Sofiène Tahar from the Concordia University. Okay, he will talk about the challenge of the design and the verification of the cyber-physical system. So, physical system which is connected very tightly with the computation system. We will have that discussion. I'm sure it will be interesting. We will have the discussion. And the second guest, our guest lecturer will be Profesor Sarwono from ITERA. I don't know if I should talk in English or in bahasa Indonesia because Pak Sarwono akan menyampaikan lecturenya dalam bahasa Indonesia. Okay, so don't worry, Profesor Tahar, he understand very well bahasa Indonesia, right? Okay, Pak Sarwono akan bicara soal bahwa kalau kita punya sistem komputasi, kita tidak bisa sepenuhnya menyerahkan soal security itu software saja. Penting untuk Indonesia untuk tidak rely pada 100% pada hardware-hardware yang didesain di luar negeri. Jadi ada dua alasan kenapa Pak Sarwono menceritakan dalam bahasa Indonesia, karena pertama adalah ini soal bagaimana hardware security untuk Indonesia. Jadi fokusnya di situ. Oke. Yang kedua nanti diceritakan Pak Sarwono. Oke. Oke, that's my introduction today, and we will have Professor Tahar to give the lecture. I will not read your biography because I believe that you will tell about yourself first. So, okay, okay, please, Mr. Tahar. Use this because there are, uh, yeah, not in this room but online. We have some attendee online.
So thank you very much for the introduction, Prof. Arif. So I'm very glad to be here. And then I thank very much Prof. Sarwono for inviting me and then for arranging, this talk here. So my name is Sofiène Tahar. So I'm originally from Tunisia, so which is a small country in North Africa, close to Morocco. And then I have studied all my degrees in Germany, then moved to Canada. So, and currently I'm a professor at Concordia University, which is an English-speaking university in Montreal. So, just to give you an idea about, where is this located. So basically, so this is now the map of Mexico, and soon this will become just the map of the United States, if you're following the news. including Greenland. Right? All of this soon will just become the United States. So if I come next year for another talk, maybe I present another map. So where is Montreal? So Montreal is just here. So we are at the border of the US. From Montreal, from my office, I can see the mountains of New York State. So it's really very close. And then many people say they like to come to Bandung because the weather is cold, right? But this is nothing compared to the cold we have right now in Montreal. So yeah, I was saying that it's really very, very cold at the moment. Okay, so we're talking about minus 21, but it really feels like minus 30 because of the wind. And then, you'd better don't come to Montreal these days. All right. So Concordia University is one of the major universities in Canada. We have 50,000 students. We have 4 faculties, and I belong to the Faculty of Engineering. And then in the Faculty of Engineering, we have about 10,000 students. Among them, we have 3,500 graduate students. This is the largest graduate student population in any university in Canada. We have 5 departments, and I belong to the Department of Electrical and Compute Engineering. So in my department, so we have 2 degrees, electrical engineering and compute engineering. And then for compute engineering, so we have 2 options, hardware and software. So myself, so I'm a professor of computer engineering hardware, okay, and this is where I belong. So in terms of population in our department, so we have a total of 700 graduate students that are supervised by about 46 academic staff. And then you notice here that the number of students in computer engineering is double the number of students in electrical engineering. This is because of the economy of things are. Now, in my department, there are several research groups. So from control to telecommunications, VLSI. And then so my research group is called the hardware verification group. So this group, has been established, since a while. And then our mission is to develop methodologies, algorithms, and tools for something we call formal verification. And I'll tell you later on what is formal verification. And then we are interested in verifying hardware systems, like, microelectronic systems, as well as embedded systems where we have hardware and software. And then more recently, so we're looking into cyber-physical systems. And again, so I'll come to tell you later on, what is the definition of cyber-physical system. So currently we have about more than 20 researchers, like a number of, academic staff, and then we are supervising a number of PhD students and postdocs. This is the timeline of our research over the years. So when we started, this lab, we were more working on telecommunications hardware because that was the main industry in Canada, okay? But things, have shifted over time. So system on chip became, something very important. Like any phone today, inside it, there is one single chip, which has all the processors and all the computation. It's the system on chip. We were looking at digital signal processing, security protocols, analog and mixed signal systems, optical systems, and then more recently into cyber-physics, which are including the hardware, software, as well as physical devices. All right, so this is the outline of my talk. So I'll first start with explaining what is a cyber-physical system, then talk about what are the design requirements, for such a system, then the challenges and risks, and then what people are using in terms of analysis. And then if time permits, so I can go over some case study where I show you the challenges, that you have to deal with if you want to verify some photonic devices used for optical sensoring. So then I draw some conclusion, just to see basically what we have and put ourselves on the map. All right. So talking about cyber physical systems, it's all started with embedded systems. So embedded systems are actually everywhere. So you have a car, an airplane, you have a phone. So so you have a computing which is dedicated for a specific application, right? Unlike regular computers and processors. So the bottom line of an embedded system is that you have some digital hardware, and then you have some embedded software, which is the brain, and then it is running on top of the existing hardware. So if you take a car, for example, so a modern car today has about 100 processors. And then on each of these processors, there is some software that is running, right? So it is an embedded software. It's not like the software you have in your computer, meaning that if something goes wrong, you can't, just plug in a screen and then, start looking at what's happening. You have to take it to the dealer because, they have, specific software and hardware to access, the computation that is in the car. Now, in addition to this, there is an increasing number of sensors and actuators and smart control that is embedded in cars today. So not only there is like, this software and hardware, but you have, for example, sensors, sensing a distance between you and the car in front of you. You have sensors basically for humidity. You have, sensors for all kinds of means. And then, so these are communicating with the hardware. So you have sensors, will run the software, make a decision. Then once the decision is made, then, it sends back the device. Then this is, how things are done. Now, in addition to that, so we are introducing or including more machine learning and artificial intelligence into that, meaning that the embedded system plus all the physical devices plus all the feedback. Now it's not just controlled by the driver, but it could be autonomous driving, and then so there is lots of machine learning that comes into the picture. On top of all of this, and then I'll mention this later on, we have a lot of communications that are happening when you are driving a car. So you see all of these. Unfortunately, this one is not pointing up. So you have basically inside the car, so Bluetooth, you have Wi-Fi, you have GPS, you have satellite communication, you have also like cellular communication, right? So, and all of these communications, so they're happening while you are driving. And then it allows the car to be also connected, so with other cars and connected with a highway. So, if you look here at all the cabling that is inside the car, so sometimes we have like a few kilometers of cable inside one single car. And this is really a lot. So in addition to wired communication, we have lots of wireless communication. This is all nice, but it comes with a number of issues that I'm going to address later on. So, going back to the embedded system, we have the digital hardware and the software, and now so we are adding the physical components into it. These are all the features that come around. So now, if we put all of this together, so a cyber physical system, we have three main components. One is computation, one is communication, and one is control. Okay, so this is very, very important. So a definition, a very simple definition for a cyber physical system, it's an integrated physical and cyber component where the relevant functions are realized through interactions between them. So cyber means the computation and the computation, right? So this is all the software basically and the hardware that is doing the job. And physical are the physical devices, like the sensors and actuators, as well as your environment. And this is all together making the cyber physical system. Now, the problem already we can see here is that if you want to build and verify and design and implement a cyber physical system, you need somebody from the computation, you need someone from the communication, and you need someone from the control area, right? To this feedback. And these are three different communities. So if you have a paper, for example, that you want you have in communications, you have to submit it to a communications conference. It won't work in like, in a hardware design conference. If you have a paper on control, so you have to go in this community. And each of these community, they speak different languages. They have different standards, different notations, and so forth. All right. So just to give you a concrete example, so if we think about the cruise control in a car, so for cruise control, so you put at a certain speed, and then the car will adaptively adapt the speed according to the cars in front of you. So we have here some sensors that are, checking the distance between you and the car in front of you. And then, so if it is sensing that the cars in front of you are closer, then the information will go from here, then to the hardware, so from analog to digital. Then the processor so will do some computation. Then afterwards, if it decides that we have to brake, then there is information that goes from digital to analog, then to the actuators which are here in the brake, right? And you see here the feedback. So from here, physical to digital, software, then again to digital, then analog, and this is the kind of feedback that we should be going. So that's basically how the measurement is done through the physical part. Then in the cyber part, so we have a piece of software is saying if the speed is a certain threshold, and then so the distance is like that, then you do certain, right? So now the problem with all of this is that we have a combined reasoning. Why? Because we have to deal with the physical parts, we have to deal with the hardware, and we have to deal with the software, right? Then all of this has to work properly together, meaning that if the sensor is sensing something wrong, then the hardware will not be able to detect it, and the software will do something wrong, right? But if the sensor is working well, but there is a failure in the hardware, then the software will not work either. And again, if the sensor works and the hardware works, but there is a bug in the software, let's say here instead of -10, by mistake they put -100, then again the car will crash, right? So there are many sources of errors and mistakes, that can lead, to failures, and that's, something that we need to be very careful about. So now this is the summary of, the process, the physical parts, the sensors, the cyber part, maybe the network, so things can work for wireless, then the actuators, and then so this is why we need control systems, to deal with this kind of feedback. So the main goals are to co-design cyber-physical system part of the system, and then so to make a system of systems, right? So what I was mentioning here, one part, but the car has many of these. Car we can consider as cyber-physical system of other cyber-physical system of systems. All right, now cyber-physical systems, it's not science fiction. So it's really something that is used today. So automatic driving, human robots collaboration, smart grids for power, automated farming, air traffic control, and then surgical robots. So, and this is something that is becoming very popular in the healthcare domain, where this is the surgeon, this is the patient, right? And these are basically the assistants. So the surgeon is not doing the surgery on the patient, but there is a robot that is doing the job. And this robot is controlled by the surgeon, right? Now, why do they do that? Because if you want to go very fine grained, if you want to use laser or something really very, very small, millimeter or sub-millimeter, surgery, then you cannot do it by hand. You have to use other tools, right? That are very precise. So the doctor here is doing the surgery while, looking at it. Then he has like, maybe, right? Now, if this is very successful and then it is working, this is also a cyber-physical system, right? So it has physical tools, it has here the computation, and then there is software that is running. So if something goes wrong, then the surgeon will not be able to see it. But he has here assistants that tell him, well, look, you're going too deep, right? But sometimes it's maybe too late. So now, what is the future? currently, so we are noticing all over the world that there is a lack of surgeons all over the world, especially in remote places. You go to some places very far from the big cities. Now, if the surgeon can be here, manipulating the robot here, and this is, for example, in Jakarta, right? Then we can imagine that the surgeon can be here in Bandung, right? In front of the computer. And then so with Wi-Fi communication or cellular communication, he will communicate with the robot that will be in Jakarta, right? So the patient and the robot will be in another city, and this one will be another city. This is all very nice, but it comes, with some issues. All right. So some people say that the future is already here, but if we look at the next industrial revolutions, so many people think that cyber-physical systems is really the future. So if you look at all of this was mentioning, plus AI and machine learning, so this is, many people say, the next industrial revolution, that we are living right now. And every day, there is something new that comes to it. All right. Now, if we look at all of these devices in operation, then I was already hinting to some issues, that can come. So the first one is safety. So we have to make sure that these systems, they operate correctly, right? And safety means if there is a failure, then it can cause injury or death. So like, a car accident, for example, or basically a surgery issue. Now, there is another point, which is the cost criticality, meaning that if there is a failure, so let's say, so I have a new robotic surgery system, and I'm a new company, and then so I have it on the market. Then it happens that, somebody died. You know what's going to happen the next day? I'm going to close my company and file bankrupt, right? Same thing with cars. So if I have like, an autonomous car and then there is a crash, right? Then, if I'm a small company, I'm going to just, bankrupt. But if I'm a big company like Tesla or so, then they're going to pay millions of dollars or hundreds of millions of dollars and just, continue business. All right. So now, if we put all of this together in terms of mission criticality, then if there is a failure, so not only there is like, injury and death, but also financial loss and discredit. This is why, so the main goal is to make systems more secure, more robust, and fail-safe. Very important. All right. Now, what is safety? Safety is to make sure that such systems interact with the environment in a correct way. And then so the correctness depends on the logical results and the time in which, they are produced. So you have a number of properties, and then these properties, has to be all satisfied. Performance is another issue. So, for example, if you talk about safety and then you say, okay, in order for the cars, autonomous cars, not to crash, let's only drive them at 20 kilometers per hour. Very, very, very slow speed, like when you are in the traffic in Jakarta, right? Very low speed. However, I mean, nobody likes that. I mean, I would like to drive faster at some point when there is no traffic. So this is why performance is important. On the other hand, there is cost that comes into the picture. So I don't want, these devices to cost millions of dollars. So I want a car, that cost me maybe like, $10,000, $20,000, $30,000. So the other issue is interoperability and security. So meaning that if you have lots of systems and subsystems that are connected together, are they adhering to the same protocol or not? And then, come another issue on top of it, which is security. So I was talking earlier about this system, this, robotic system. Then I was telling you that I was telling you that this surgeon here can be in another city. Now, what if through the communication an intruder comes, right? And then, he just like, blurs the signal so that, if the surgeon wants to go just 1 millimeter deep, then he will go 5 millimeter deep, right? So in addition to safety, we have a problem of security. Now back to the cars, And then back to the all the devices that are around that I mentioned to you. So you have all of these communications, right? So this is all nice. But what if somebody is capable to enter into the communication between the car and the satellite, or between the car and then the cellular or the Wi-Fi or the Bluetooth? Then you know this can create a number of problems. Why? Because we have the sensors and the actuators that are communicating using Bluetooth and Wi-Fi. We have the cars that communicate, you know, with the environment. Remember, it's not the physical system. It's about the physical devices and then the environment, right? So GPS, cellular, and then so highways are connected to control stations, also with satellite and GPS. So, and now so we have another problem, meaning that in addition to safety, we have to look into security, right? So it can be safe, it can go from A to B with no crashing, but if it is autonomous and somebody, you know, can get into the system, then, you know, hello problem. So for example, so I was mentioning here, you know, this issue of measurement of the sensor, the physical part, and then so here the software, right? So if I am capable to get into the software that is installed in the car and then make a change of this from 10 to 100, right? So a hacker can do this. Then, you know, you can have a crash, even though it was built, you know, in the correct way. So the question is, are we prepared for that? So if we look at how the operational risks, you know, are done today, so we have lots of big data, so lots of information is in the cloud. And then everybody is communicating. So you can communicate from the house, from the car, from the manufacturing, from, you know, office and so forth. Meaning that if you are driving here a car, so I can be here at home and then have access to the car. So I give you an example. So if you have, if you are driving a Tesla, if you own a Tesla car, so and then there is an app, Tesla app, and then on the app you can see the car, where it is, at what speed it is driving, right? So if the air conditioning is on or off, what temperature, lots of information, you can see it remotely. So let's say so I have the app, and then so my son or my daughter is driving the car. So I can remotely, and this is the reality. So I can remotely change the speed of the car and change the air conditioning or limit the speed of the car, right? So now if I can do it while my son is driving the car, meaning that if you happen to have my phone, you can also do the same thing, right? Then you can limit, you know, the speed of the car. Now, Tesla cars, they also they have a feature to be autonomous at the same time, meaning that if I have that feature on, then I can actually get the car to come to this location. So you leave the car at the center of the city, right? Braga walk, and then so you can ask the car to come here. Now, if I can do this, you can do this, then a thief can do it as well, right? And this is all the problems, you know, that come with it. So it is nice, we like it, but, you know, if we can have control, imagine that the president is in this car, right? And then his car has all of this technology, then I can cause a crash if I'm capable to do that. All right, now, are we prepared for that? Now, we have to be careful that we have a continuous operation, continuous business, and then, you know, emergency management. If something happens, we recover. However, if things are going really like, you know, real time, then in addition to the safety issues, there's the security issues. So there is risk management, there is also crisis management that come in. Now, there is another thing that comes on top. So we said safety, security, but there is also privacy. Because if I go back to the Tesla car, so when you buy a Tesla, so you have to enter your information, your name, your address, your phone number, your email, maybe your date of birth, your ID number, and so forth. And it's all in the cloud. Now, if you have somebody that is intruding into the system, he can also have your private information, right? The surgery is even worse because you have, like, you know, health information that comes into it. And that's why, people are talking about cyber protection, right? All over the place, all over the world, even like, here in Indonesia. Now, there are some real incidents that happened. So this is an example of something in India. The electricity grid fails, 620 million people without power. Why? Because it is a smart grid. And then so you can wirelessly access, the grid. And then, you can, have harm like that. You may say, okay, India is a developing country. They are not so secure. But also in the US, people were capable to get into the US Department of Justice, right? Well, what about cyber-physical systems? Well, here's something which is even like, weirder. So, new cyber concern, hack attacks on medical devices. Patients put at risk by computer viruses. So what does it mean? Well, so some people, they have heart problems. And then so they have here an implant into their heart, to do like, some defibrillator, right? So once you have an implant here, then that one needs to be monitored. So this means like if you are at home, there is a nurse somewhere that is checking, your heartbeat. If you have any issues, then they intervene. So the communication between this one and the hospital is wireless, using cellular, for example, right? So now if this happens to be, I'm just giving an example, the president or the minister, right? And then so, and you have access to this wirelessly, then you can imagine, what can happen. So some people actually, they found out that some systems that are really in place, they can basically provide inappropriate shocks, or appropriate shocks are not delivered. And then, there are like papers about, how this can happen, right? So it's really, so another example is for people who have diabetes. So you have here an insulin delivery, which is also working wireless, right? And then so because of that, you can also have security issues. All right. Now, all of this is leading us to one important point, which is how do we make sure, that these systems are working properly? And then verification and certification becomes here very essential. So, and in particular, verification. Why? Because if you look at the industry today, if they are spending like, let's say $100 million on the product, then probably 70 to $80 million will be spent on verification, and only 20 to 30% on the design. Because designs are very complex, and their verification becomes even more complex. So what do people use? So they use maybe like, paper and pencil methods, simulation, or some computer algebra. They all come, with some drawbacks. This can be error prone and tedious. This basically has only like, approximations. You cannot cover all the possibilities. And then sometimes they have, some soundness issues. And there are people who have wrote papers on how some publications, with very good citations, still they have, some bugs into them. And then also systems that are on the market that also present, some bugs. So, and now I come to another alternative technique, which is called formal. So what we want to do here is to solve, the problem of paper and pencil and simulation and computer algebra, in the sense that, so we want to do a mathematical model using a computer. Now, we don't want to do simulation where we are simulating like a few test benches, a few cases, but we want to do some algebraic computation that is covering all the possibilities. It comes, of course, with some drawbacks, and then so I'll be talking about this in short. So formal verification is basically to use computerized mathematical reasoning to verify systems. And then it's already like, standards like DO 178 and so forth in aerospace, automotive, and electronics. So it's not something totally new. So when I did my PhD in the 90s, so I was already using formal methods. All right. So one important point here is the fact that we have a loop. So you design, you have the requirement, you do your implementation, you do the verification. If everything is good, you're done. If not, then basically you have to fix your design, and then this can go for very, very long time. This is why sometimes when you have aircraft that are delivered, they are delayed by lots of months, like 2 months, 3 months, 4 months, 9 months, 10 months. Why? Because the verification loop so is taking longer than expected. So just give you here a comparison between testing using simulation and formal verification. So this one does not require knowledge. It's automated. But this one, basically, you need expertise, but you have guaranteed correctness. Now, I give you here, like, a case of a drone. And there are two well-known companies, Lockheed Martin and then Rockwell Collins. Very big companies in the US, and they're specialized in making like military, equipment, including like drones. Now, for the same system, so when they used testing using simulation, they found no bugs. Everything is fine. However, when they used formal verification, which is the mathematical reasoning, then they found 12 mistakes. And this is a problem because if one of them is there, then the drone will crash, and then this will be disastrous. So now, what about numerical simulation? So the problem with numerical simulation, if you don't have a closed form solution, especially for nonlinear systems, is that the tools like MATLAB and so forth, they use lots of approximation, right? So we cannot basically trust them a lot. So if we look now at the types of properties we are interested in, so if we want to verify any system, we want to verify safety, for example, stability, security, and privacy. So if we take the example here of a drone, so safety means that the drone is stable. When it comes into a position upside down, then it comes to the right position, it reaches from A to B. Security means that if my drone, I'm sending it from here to any location here in Bandung, then nobody can get into the system, then, take the drone or, make it fall or go to another direction. And privacy means that if the drone is carrying some sensitive information, that sensitive information should not come into the hands of like any intruder. And then all of this combined, becomes very difficult. Just about safety, so you have to deal, with mathematical models of the dynamics, continuous dynamics. You are basically in certain states, you can go to some other states. So you have some stable locations, not stable locations. We talk about reachability from one point to another point. We talk about trajectories. So I'm just mentioning, some of the mathematical issues, that are here important. We talk about equilibrium, so that the drone, will be stable. So another type of property, that needs to be taken into consideration. So this is like, an example of a property. When the drone is upside down, then within 2 seconds, it has to come to the right, position. So, and then there are endless properties like this that need to be modeled and verified. And my friends, this is only the safety part. All right. I'll let the Prof. Sarwono later on talk about the security part of this. So now just to summarize, so if we want to use any verification system, so we need to look at scalability. So is it capable to look at complicated systems? Expressiveness, automation, accuracy, soundness, and if it is mechanized, like automated. Then you see that, all of these techniques, they have advantages and drawbacks, including one technique of peer improving, one kind of technology for formal verification. All right. Do I have how much time? 5 minutes? 5 minutes. Okay. So very quickly, I want to show you how difficult it is to deal with cyber-physical systems, in particular when there are like, physical components that we need to take care of. And this is one example of physical devices called photonics integrated circuits, where we have to be careful about the speed, the reliability, the power, and the cost, right? So where are these used? If you remember, so we had like, this example of Tahar, and then, these are the sensors that are measuring the distance. So they are based on photonics integrated circuit. All right. Now, if people want to deal with the photonic devices, then we notice that there are different modeling approaches. So everybody is modeling in a different way, depending on the angle you look at it. There are limited, CAD tools. It's not like, when you are designing, some piece of hardware, maybe processor or something like this, then you can use cadence, synopsis, mental graphics. So it's not like that. And there is no standard design that you start with, let's say system Verilog, then you have RTL, then afterwards you have gate level, transistor level, and so forth. In addition to that, these devices can be safety critical, right? And mission critical. Then so in terms of cost, we have to be careful about that. Now, these are the different approaches that people are using to reason and model photonic systems. They can look at them from the control engineering point of view, from the signal processing point of view, or from the dynamical systems point of view. So let me explain. All of these, so they come up with properties to be verified. So you have a model, different properties, to deal with. Once you are satisfied, then you start, the realization of these devices. So if we look at it from the control engineering point of view, then a photonic device, so you can represent it, through blocks like these, block diagrams, and you use transfer functions, and then you verify some control theoretic properties like feedback, deadlocks. If you look at it from the signal processing point of view, then you have here lots of difference equations. You use probably like, Z transform, and then so you reason about the properties in the frequency domain. Now, if you look at this from the dynamical systems point of view, then so you can look at these devices from the electromagnetic equations, and then use some transfer functions, and then you have some other photonics properties, that you need to verify. Now you may question, why do I need different modeling techniques? Well, because the properties that you're interested in are different. So using transfer matrix modeling, so you look at the transmittivity, reflectivity, cascading, and so forth. With difference equations, you look at linearity, scaling, frequency response. And then with block diagrams, which is the control part, you look at feedback and you look at basically at rejection ratio. Now, when people in industry that are making these devices, they want to verify all these properties, right? And that's why, they have different teams that are doing different modeling with different skills, and then, conducting the verification. Now, one of the work that we have done in my research lab is to use one frame, one language, right, in order to specify all of these issues. The block diagrams, difference equation, dynamic equations, it's all in one language, in one system. Then we have provided here a library of photonic components. And this is like one PhD thesis, basically. Actually, it's three PhD theses of students. One was working at each of these. And then so we have now a tool that is capable, to deal with that in one framework, one language, and in one software. Okay, so will this work in the future? So it depends. But important here is that we need people to collaborate together. So we spoke about people from control, people, from communications, people from, the computing, hardware and software, computer science, computer engineering. And this is all important, to work together. Now, before I conclude, I just want to highlight here something important, which is I defined what is a cyber-physical system. I defined what are the requirements to design. I defined, how to verify them, then what are the issues, right? But one question remains is, are cyber-physical systems affecting us as human beings? So we are using them, right? And we make sure that they work, they're secure, and so forth. But at some point, all of these devices and all of this AI is going to affect us. Just to show you here a picture. So these are people that are watching, some performance concert. Now, in 2013, this is how it looks like. So are people enjoying the performance, or they are recording it, or they are sharing it, right? I'm not sure. So now, if we even move forward, then if people are meeting somewhere in a restaurant, so they're not talking to each other anymore. So everybody takes a phone, chatting or doing something. Then in addition to that, the waiter is no more a human being, right? So nobody's going to ask you, how are you today? What do you like? Is it like too hot for you? Is it this? Is it that? Then if we can imagine that, we are served with this, and then we are becoming that kind of robot, then this is the problem. So today we talk about addiction, to smartphone, right? Especially with kids. Then also we adults, we are slowly, unfortunately, suffering from that. All right. So this is what we call the human in the loop. And this is a very, very hot topic right away, called cyber-physical social systems, so CPSS, right? And then people are looking at how CPS are operated by humans in the loop. How do we reason about human behavior, right? And then modeling that human behavior is difficult because you need to collaborate with people from the psychology. So if you want to do a project like this, you need to talk to the Department of Psychology. Then, try to do this. Now, modeling human behavior using some tools is also difficult. And this is the problem. There are lots of jobs in this area, right? But all of these jobs, really, they require multidisciplinary skills. So all students, if you want to work in cyber-physical systems, you really need to know about hardware, software, physical devices, also control, right? Then in addition, so you need to know about safety, security, privacy, and then so to be able to get, some of these jobs at these, top companies. So I presented just one of my research work, but, you can find more about this on our webpage. So we have lots of ongoing projects on physical system, transportation, and support. You can have a look at them here. And then some of my students with like the webmasters, they was checking is our work that we do relevant. And these are some statistics on every month. So how many people are making page loads? So it means like they're downloading papers or like, some software that we have developed. And then these are like, the unique visitors and returning visitors. And then so we push it a little further through like, Google settings. And then so we are capable to see where are these people coming from. This pins, it means like a large number, like, 200, right? Then it's mainly from the US, Europe, a little bit here from Asia, like, China, Korea, Japan. But there is nothing coming from Indonesia, right? And then the purpose of me being here today, and by the way, day before yesterday, so I was in Surabaya, so I gave a talk at the ITS. And then on Monday, I was at the University in Indonesia, so in Jakarta, I also gave like, presentation. And then so throughout my visit here, so I wanted to just explore opportunities for collaboration, right? So for student exchange. All right, so with this, I come to the end of my talk. I would like to thank all the students doing the job, right? This is to show you that Montreal is cold now, but in the summer, you can enjoy barbecue in the outing. So this is some of the social activities we do with our research group. And then with this, so I thank you very much. So Terima kasih, everybody. And then so I'll be pleased to answer questions. Thank you.
Thank you for the material. Very very interesting. We will push the discussion later. And for now, I would like to invite Professor Sarwono for the course. Please, silakan Pak Sarwono.
Baik, terima kasih. Terima kasih untuk yang hadir di sini. Terima kasih hadir di Zoom. Kalau saya tidak akan mengundang Anda S2, S3 di ITERA, karena di ITERA belum ada S2, S3. Jadi, tapi saya ada beda ya, beda tujuan. Dan untuk gamifikasi, saya ada hadiah 3 buah buku Ketahanan Cyber Indonesia, dan ini akan diberikan pada 3 pertanyaan terbaik dan 3 pertanyaan atau diskusi ya, yang nilai Pak Arief ya. Baik, jadi ini sebenarnya inti dari buku yang di launch ya sekarang ini dengan presentasi ini sebenarnya. Dan ini ada tulisan apa? Oh, di ini kan aja. Oke. Nah, jadi tadi dari presentasi Profesor Tahar ini akan jadi bahan diskusi kita. Dan oke. Terus terang pekerjaan saya ini dibantu asisten yang huruf pertamanya adalah G dan C. Anda tahu apa? Gemini dan Cloud. Ya. Itu asisten yang paling setia. Jadi ini benar-benar dipilih ininya, judulnya memang ini levelnya bukan hanya teknikal, tapi nanti banyak politik perdagangan dan sebagainya demi kedaulatan Indonesia sebenarnya. Tapi dasarnya adalah teknik elektro dan teknik informatika. Oke, jadi ini cyber itu udah jadi bukan hanya di jaringan, tapi ini juga ini mungkin akan menyinggung sedikit dari lab sebelah. Jadi era smart city itu udah habis. Sebenarnya sekarang adalah Siber-Fisik. Jadi tadi diceritakan bagaimana mobil dikendalikan sehingga mungkin bisa diubah tujuannya. Dan ini ada bukti nyata ya. Jadi di Indonesia 2024 itu 282 instansi ya di Indonesia nih. Kemudian juga ada kinetik tadi Siber-Fisik, jadi mungkin blackout listrik atau PDAM ya. Jadi keamanan cyber itu bukan isu IT ya. Kalau di kami auditor TISA, IT itu bukan information technology tapi information and technology ya. Itu bedanya kami dari ISAKA. Ini isu keselamatan negara. Oke, jadi ada istilah APT mungkin teman-teman belum ini. Jadi dia memang bertujuan masuk gitu, advanced persistent threat ya. Nah ini ada aktor negara, bukan hanya bocah nakal atau iseng-iseng. Nah ini kemudian kill switch. Nah ini jadi ini ada istilah dwell time. Dia masuk jaringan tapi nggak ketahuan. Itu bisa lebih dari 10 tahun. Bisa lebih dari nggak ketahuan. Dan itu memang bisa terjadi kata asisten saya ya. Dan ini udah sampai ke intelijen negara asing. Dan kita sekarang itu kebanyakan ke aplikasi OS, tapi sebenarnya di perangkat keras pun bisa sengaja ditanam semacam Trojan horse. backdoor gitu. Bukan hanya di hardware ya, di firmware juga. Nah, masalahnya yang mengerjakan firmware di ITB siapa? Di elektro hardware software. Di IF itu hanya software mungkin. Nah, firmware mungkin eh, bisa didalami juga. Oke. Jadi ternyata ada eh, peraturan perundangan Indonesia juga ada risiko hukumnya nih. Nah, masalahnya kita hampir semua jadi import. Jadi, nah ini 5S, mudah-mudahan tidak ada dari kalangan Intel yang hadir. Oke. Nah, ini intinya buku saya dan presentasi saya. Jadi kebanyakan kita itu hanya aplikasi. Jadi dilihat pakai antivirus, aplikasinya ada virusnya atau tidak. Di OS, oh OS-nya update, vulnerability-nya dihilangkan. Nah, bagaimana dengan Trojan horse di BIOS atau di firmware? Apalagi di hardware-nya. Dan ini sudah ada yang dibuktikan ya di kalangan black hat itu ada yang level BIOS, ada level hardware. Nah, teman-teman yang belajar IC design, tadi ada diskusi di sebelum masuk sini ada unclonable. Itu buat mencegah di copy desainnya, tapi juga memeriksa bagaimana hardware itu ada Trojan horse atau tidak, itu nggak bisa kalau chipnya sudah jadi. Nah, kalau di sini, nah kalau itu didesain dibuat di luar negara ini, ya kita nggak bisa kontrol. Jadi ini inti dari buku saya ya. Nah, jadi side channel attack, jadi side channel attack itu bukan di kabelnya yang diperiksa, tapi power consumption, lalu juga EM radiation, electromagnetic ya, bisa itu dideteksi kuncinya dan sebagainya. Dan ini kalau gini khusus mikroelektronika ya. Kebetulan paper saya agak paper S3 saya bukan paper saya ya. Ini di power analysis. Nah, jadi solusinya ya desain chip sendiri sebenarnya. Ya, singkatnya gitu. Nah, ini studi kasus ya. Misalkan smart grid di PLN. Jadi memang level di perusahaan mungkin dia tinggi, di consumer ya lumayan lah ininya tingkat keamanannya. Nah, tapi misalkan kamera CCTV ya CCTV, lalu gadget Anda ini kemungkinan low dan ini bisa langsung loncat ke objek vital. Objek vital itu bukan hanya punya negara ya. Misalkan tadi dikatakan mobilnya bisa bergerak atau pisau operasinya harusnya 1 mili maju dimajukan 5 mili ya kena pembuluh darah dan sebagainya. Jadi prinsip keamanan adalah keamanan total itu adalah keamanan yang paling lemah. Nah, kita langsung beli CCTV, kita langsung beli USB mungkin nggak diperiksa atau punyanya Indohome di rumah. Gitu. Yang penting adalah fungsional dan keamanannya jarang disentuh. Kalau ada pertanyaan langsung aja ya. Tapi saya mempercepat karena saya ingin lebih banyak diskusi nanti ya. Dan kemudian AI. Jadi AI itu selain ada positif, negatifnya adalah memang dipakai oleh hacker untuk lebih pintar lagi untuk masuk ke model atau modelnya diracun dengan yang lain, maksudnya diharapkan tuh diubah ininya ya. Dulu kan ada berita AI-nya itu membedakan orang hitam dan orang putih itu sehingga kalau orang kulit putih karena lebih banyak di train, dia bertindak lebih positif untuk orang kulit putih. Jadi rasis juga bisa AI ya. Nah, kalau deep cap udah biasa ya. Nah, di sini ditekankan slide ini dengan merah. Jadi bagaimana chip AI itu lebih positif, lebih banyak manfaatnya untuk Indonesia jika itu dirancang sendiri oleh Anda sendiri di dalam negeri. Oke, nah ini tinjauan keuangan. Bikin chip sendiri lebih mahal atau ada masalah terkait cyber-physical, listrik mati atau nanti kendaraan tabrakan atau keretanya terguling karena IoT-nya kena, kamera kena, lalu sinyalnya kena. Jadi ini harus dipahami dari semua segi, bukan hanya uang ya, bukan hanya murah, tapi juga keamanan negara bagaimana. Nah, Pak Isan, Pak Adi telah inisiasi laptop merah putih. Ya, jadi kita baru PCB lalu apanya gitu. Nah, kalau bisa itu sampai TPM-nya itu buatan dalam negeri ya. Ininya BIOS-nya firmware-nya belum diperiksa. Nah, teknik elektro mungkin bisa masuk ke firmware ya. Walaupun laptop merah putih ini hanya merakit, tapi sudah ada kemajuan. Nah, ini mudah-mudahan ada kolaborasi hardware security itu ini kan, lalu talent factory. Jadi Anda ini akan jadi leader-leader atau champion. Nah, foundry kita belum punya. Nanti ini level negara ya mungkin ya. Jadi bagaimana kolaborasi, ini iklan ITERA ya. ITERA itu apa sih? Nanti dipertimbangkan hadiah buku ya. Oke. Nah, jadi ini terus terang belum bicara dengan Bappenas, belum bicara dengan PO Mikro, tapi kira-kira harusnya 3 tahun lagi itu hardware security modul itu udah bisa buatan sendiri. Kalau chip paspor sudah dimulai Pak Arief, mudah-mudahan chip paspor Indonesia itu buatan Indonesia sendiri. Nah, sehingga ekosistem negara yang besar ini dan surga ya Indonesia itu karena di bawah-bawahnya banyak air itu bisa diwujudkan. Kemudian kalau ada side channel vulnerability itu bisa juga diatasi karena kita desain sendiri, kita buat sendiri. Nah, jadi Indonesia kata asisten saya itu sudah ada OPFIT, ada peraturan perundangannya. Nah, tapi audit itu kemungkinan auditor-auditor kita itu karena banyak basis dari keuangan belum bisa ngaudit teknologinya. Nah, ini mudah-mudahan dari teman-teman Unhan, BSSN, ada sekolahnya itu juga ke sana. Nah, TKDN itu diperjuangkan oleh Pak Adi, itu baru nilai ekonominya. Bagaimana nanti TKDN yang baru itu juga dikasih bobot keamanannya. Nah, ini teman-teman kita di DPR dan pemerintahan ini mudah-mudahan bisa bisa ke arah sini gitu. Jadi TKDN bukan hanya nilai ekonominya juga. Nah, BSSN alhamdulillah sudah ada lab common kriteria, jadi udah bagus. Jadi tinggal DPR untuk menentukan instansi apa itu harus common kriteria EAL 3 atau L4. Kalau paspor tuh EAL berapa ya? 5 plus. Itu mungkin pengalaman pertama ITB nanti membantu suatu device sampai EAL 5 plus. Siapa yang belum tahu EAL, nah nanti tanya asisten aja ya. Nah, jadi sebenarnya kalau bisa diproduksi sendiri, di dalam didesain sampai produksi, itu dua-duanya keamanan juga, ekonomi juga. Jadi bukan hanya menjual hasil bumi, tapi juga ada pertambahan yang lain. Nah, mudah-mudahan 2045 atau sebelumnya itu ada kedaulatan yang kita. Jadi infrastruktur gimana kalau import semua, maksudnya gitu ya. Jadi ini anda-anda yang ini ya, yang muda-muda ini. Oke, ini slide terakhir mungkin ya. Jadi laptop merah putih itu bukan hanya laptopnya, tapi itu ada unsur keamanannya, ketahanan cyber. Nah, mungkin belum dikeluarkan, kalau sudah ditekankan, mungkin pekerjaan Pak Adi dan kawan-kawan dan Pak Ihsan itu tambah berat lagi. Jadi kita bukan hanya dari harga laptop, tapi juga dari nilai strategis karena vulnerability keamanan CPS itu bisa diatasi kalau kita yakin dari hardware, firmware, dan software itu sudah diverifikasi. Nah, kemudian juga rantai pasok. Nah, dalam kegiatan Merah Putih sebenarnya kita juga Pak Adi dan kawan-kawan itu value chain juga kita kita bujuk supaya ada value chain yang baru, bukan hanya dari grup Jepang, dia nggak mau nerima dari grup lain, lalu grup lain nggak mau nerima Jepang, kita buat lagi, kita dorong supaya value chain itu bisa berjalan. Nah, kemudian juga di sini eksplisit hardware security. Jadi SDM punya kompetensi, punya knowledge tentang hardware security, bukan hanya fungsional hardware security. Dan pertahanan yang ini adalah level silikon. Nah, ini terus terang dari Kemhan itu belum sampai sini, nggak tahu di Sesko atau di pendidikan di atas ya. Tapi mudah-mudahan dengan adanya buku ini bahwa keamanan itu sampai dasarnya itu harus diperhatikan. Saya kira sekian dan mudah-mudahan banyak yang ingin hadiah buku nanti dicatat oleh Pak Arif. Saya kembalikan.
Thank you, Pak Sarwono. I would like to invite Prof. Tahar and Prof. Sarwono to the stage, and I'll so we have seen the material from the Professor Sarwono and Professor Tahar. We have seen that a lot of challenge in verification and the verification of the functionality of the safety and the security of the physical system and the critical infrastructures. And I would like to invite any question from the floor. Maybe first we want to have question from the audience in the room. Yeah, please. Would you silakan perkenalkan.
Ya, izin Pak Sarwono. Saya perkenalkan, saya Ahmad Sofi dari Stay. Eh, Penasaran dengan ini Pak, tadi yang kejadian 10 tahun tidak ketahuan tadi Pak. Itu kalau dari hasil auditnya itu apakah memang dari hardware-nya sendiri atau memang dari penggunanya sendiri ya yang memang lemah gitu. Kerentanannya memang dari hardware-nya sendiri atau orangnya gitu yang mengeksekusi. Karena tadi di akhir kan dijelaskan bahwasannya TKDN juga sudah ada security wake-nya atau memang baru-baru ini yang security wake-nya menjadi apa namanya salah satu pertimbangan lah kalau misalkan TKDN sebuah chip atau apapun ada pertimbangan security-nya. Itu sih Pak mungkin yang jadi pertanyaan yang 10 tahun itu mungkin ada di celah mananya. Terima kasih.
Langsung aja ya. Oke, yang pertama dwell time Trojan horse by software atau hardware. Kalau udah ketahuan pasti diatasi kan. Masalahnya sistemnya itu jalan normal. Nah, tapi ada Trojan horse di dalam. Jadi ada sesuatu yang bisa diakses dari luar dan itu memang itu senjata perang cyber. Jadi kalau lembaga penelitian dari negara manapun menemukan vulnerability baik software, hardware atau firmware, itu mereka akan diam karena itu senjata mereka. Oke ya, itu senjata mereka. Jadi yang membuat tabel vulnerability CF apa CSF ya, itu baik hati. Tapi kalau tentara cyber menemukan itu, wah ini harta, ini senjata, ini peluru, jadi memang sengaja dipelihara. Ada yang sengaja dipelihara bahwa itu nggak sengaja terbentuk vulnerability ya. Kalau vulnerability di firmware dan hardware kemungkinan besar itu sengaja by design. By design. Jadi atas kepentingan negara yang ingin menyerang apa Greenwich ya, Greenwich. Ya memang ada perintah dan itu ada ini, ada sejarah, ada bisa di googling. Jadi ada negara di Swiss itu kan netral, itu yang membuat kartu chip. Jadi sengaja kartu chip itu dipasangi sesuatu. Itu ada beritanya terbuka, tapi udah dilupakan orang. Jadi itu bukti. Padahal itu dia tidak membuat chip, dia hanya sebelum personifikasi apa namanya? Sebelum personifikasi ada bukan personifikasi. Jadi sebelum personifikasi itu ada membuat identifikasi kartu chip itu apa ID-nya gitu. Kayak SI kayak apa ya? Kayak alamat bukan alamat hardware lah. Itu memang dia dari pabrik kan masih blank, masih sama semua kosong. Nah, isi sesuatu. Pengisi itu memang ada kaitannya dengan begal dunia. Itu terjadi tahun 84. Oke. Lalu bisa mendetek apa enggak? Ya tergantung yang pegang infrastruktur. Oke, ya. Nah, lalu yang kedua apa tadi? Oke. Enggak, karena memang kalau bisa melihat vulnerability ya itu udah punya keahlian khusus dan oh ya saya ingat jadi pertanyaan. Kelemahannya itu bisa di manusia. Jadi dia di phishing, di apa? Dipancing untuk mengklik sesuatu, lalu klik itu eksekusi apa. Nah, itu yang paling bahaya. Memang kelemahannya di manusia. Justru awareness itu perlu. Jadi awareness itu diterjemahkan di kelompok kami itu kepedulian, ya. Bukan pendidikan ya, kepedulian, peduli nggak dia? Karena lihat sampah, oh lihat sampah tak paham gitu, sampah nggak sehat. Tapi dia peduli nggak membersihkan tempat? Oh kelamaan nih saya jawab tadi.
Baik, terima kasih atas jawaban dan pertanyaannya. Mungkin dari audiens di Zoom atau yang online ada pertanyaan? Enggak ada?
Oh nggak ada nih.
Tidak ada, oke. Oke, ada pertanyaan lain dari audiens di sini? Ya, Pak. Oke, satu. Albertus?
Oke, thank
Jangan
you.
bagus-bagus pertanyaan, nanti dapat buku.
Okay, I want to ask, we know that country like Indonesia for the emerging country, maybe for now it's hard for us to uh, make or create our own hardware, our own chip for laptop or for smartphone, for most of the communication device. So I have a nyeleneh idea. What is in English nyeleneh?
Trains or yeah, not
Out of the box idea maybe. uh, how about we make an external hardware to secure our data first before it transmit to the communication device. For example, maybe if we want to make a phone call, we use smartphone like Samsung, iPhone, or anything, and we do not trust this smartphone. So I use my own hardware, and my friend use our own hardware. This hardware, first this hardware encrypt my voice, and the encrypted voice will be transmit to the smartphone, and my friend use their hardware. They will receive the decrypted encrypted speech, and the our own hardware will decrypt it, the speech. Is it a good idea, or maybe we can use it for video or text data or anything? Maybe for developing country like Indonesia, maybe it's a good idea. Maybe, in my opinion. So, what about your opinion from Professor Sarwono or for Professor Tahar? Okay, thank you.
So I'm not expert in security, but I'm just talking from the user's point of view. So if you use an iPhone or use like, Samsung, so if you use an application like WhatsApp, for example, it is encrypted end to end. So, however, unfortunately, there are some tools that are capable to decrypt this and to know basically the communication, and then if they have access to your phone, they will be doing it. So now, if you want to use a device in between, it won't be easy. I mean, because you have a phone and then you have like something in between that is taking your voice and then it is encrypting it, but then how it is sent? Because it has to be phone. The phone is using the kind of protocol. So, in my opinion, if you want to do something like that, it has to be an app, not a hard. So an application that will be able to access microphone, right? And then within that app,
Ya, mudah-mudahan buku berikutnya adalah Digital Trust. Ini baru dalam kepala. Mudah-mudahan buku saya yang kedua adalah Digital Trust. Jadi karena kita di dalam dunia cyber sementara ini hanya menikmati bahwa oh ada internet, nyambung, bisa call ke Jepang dengan murah gitu kan. Pokoknya fungsional. Padahal digital trust itu konsep yang wajib karena kalau tadi ada zero trust, ada digital trust, kalau nggak ada gimana kita melakukan transaksi padahal itu di ruang lain. Jadi terima kasih pertanyaannya. Jadi walaupun teknik elektro, walaupun hanya desain IC, saya kira sudah mulai harus berubah pandangannya. Jadi bukan hanya fungsional, tapi juga security harus di dalam mindsetnya. Kalau enggak ya asal fungsional kamera, CCTV, tapi sebenarnya itu menaruh apa ya kelemahan-kelemahan yang bisa-bisa tadi Trojan horse-nya di hardware atau di firmware itu bertahun-tahun itu mesiu bagi negara lain ada di sekeliling kita. Dan apalagi sekarang dengan ada CCTV, lalu CCTV itu bisa di mining oleh negara lain, nanti akan ketahuan. Oh, Albert itu kalau jam segini ke convenience store belinya ini. Itu bisa ketahuan. Lalu dianalisa, oh kalau Albert ini dijadiin anggota DPR, bagus deh. Akan gampang dikendalikan untuk jadi mendukung negara kita. Negara lain. Jadi kenyataannya lebih mengerikan dari yang ada, cuma banyak teman-teman itu nggak sadar bahwa gambar dia, apa perilaku dia yang kena CCTV di convenience store itu apa ya bisa akan jadi kelemahan kalau Anda misalkan jadi menteri atau jadi presiden. Dan itu teman-teman yang elektro ini lagi membuat portofolio buat masa depan, hati-hati termasuk juga medsos ya. Nah tapi gambar-gambar di buku saya nggak ada foto karena saya ngeri foto saya tambah bisa dimanipulasi. Sama belum dapat sih fotonya dari Pak Yusuf dan sebagainya. Oke, terima kasih. Yes, the concept of zero trust and apa di zero trust and digital trust, it's I think the important not only the functionality of device, but when we design something, security mindset must be put on. Hmm. Hmm. Yes, doable. But I think there is sometimes the intruder of APT is using AI. I think if you want to communicate with someone that the content is confidential, it's better to directly speak in closed room and not near the windows. In the center of your home or building. Because the appetite of spy is very good.
Okay, thank you for the answer. Actually, it is his Facebook. So we don't trust the WhatsApp, we don't trust the iPhone or anything. So we put before we put the voice to the iPhone, we put something in the middle.
Like military. I mean,
Not-
you
not-
talk to a friend is not a problem, but when you have like military, talking to each other from different locations, they're not going to use iPhone. They're not used to use Samsung. They will use some other types of communications, usually extremely simple, right? Where I mean they can have these devices embedded. Never talk to what to. Right.
Okay, we have a question from the audience in the Zoom room for Profesor Sarwono. I read it. Sebelumnya terima kasih untuk Profesor Sarwono untuk informasinya terkait dengan common kriteria dan BSSN yang sudah melakukan. Izin bertanya untuk common kriteria CA hanya industri hardware saja. Untuk software aplikasi apakah bisa dan terbuka untuk semua industri? Ini pertanyaan dari
Terima kasih Pak Fulkom Bilal. Jadi common kriteria itu ada standarnya ya, ISO 15408 serinya bisa dilihat. Terus terang saya belum pernah mengunjungi lembaga sertifikasi punya BSSN ini di Jakarta ya, terpisah dari kantor pusatnya kalau nggak salah di Mampang ya, di Mampang. Ini common kriteria biasanya untuk device ya, untuk device. Bukan hanya software saja atau hardware saja. Nah, dengan common kriteria itu kita ada dua yang utama. Ada processing profile yang didesain oleh yang akan punya device itu. Jadi processing profile-nya itu seperti apa? Nah, terus ada dari processing profile itu PP itu diturunkan ke security target. Nah, jadi kenyataannya itu ada apa? Nah, maksudnya kekuatannya di mana saja. Nah, tapi saya akan cerita ke yang lain. Jadi dalam common kriteria itu ISO 15408 itu ada asumsi sebenarnya. Jadi device itu secure mencapai EAL berapa yang disyaratkan sesuai dengan PP dan ST-nya yang dideklar ya. Lalu ada asumsi. Nah, masalahnya contoh nyata yang saya lihat alat pembaca EKTP itu ada sampai di kecamatan, bagus di layanannya. Tapi pertanyaannya adalah operator yang pembaca itu yang ada EAL-nya di desain itu paham nggak bahwa operator itu boleh ini, tidak boleh itu. Jadi asumsi, jadi sekali lagi kenyataan human resource-nya itu yang penting. Jadi tapi kalau udah ada sertifikat sisinya EL4 atau SL berapa, itu kan kita sebagai pagar ya jaga-jaga. Nah, tapi jangan lupa bahwa environment itu juga menentukan. Jadi salah satu environment itu adalah manusia yang menjalankan. Nah, kalau software ya, kebetulan saya sekarang di informatika. Nah, ternyata kebanyakan prodi informatika itu hanya mengajarkan bagaimana membuat software atau aplikasi itu fungsional. Oke. Nah, tapi secure programming itu jarang diajarkan. Saya nggak tahu di ITB, saya nggak di IFTB. Jadi mungkin di teknik elektro mungkin secure hardware design mungkin bisa ada pilihan S2 atau S3 ya. Nah, jadi untuk software yang saya tahu ya nanti untuk sertifikasi CC-nya bisa ditanyakan. Ada yang namanya secure SDLC. Jadi tiap langkah, tiap modul itu harus dibuktikan bahwa dia tidak ada vulnerability, lalu digabungkan tidak ada vulnerability, dan itu ada best practice-nya. Kalau di ITB itu Pak Budi Raharjo yang ngajar di IF ya. Nah, bahwa software bisa disertifikasi AL berapa, bisa atau tidak, terus terang saya belum bisa menjawab. Nanti bisa saya tanya asisten ya. Terima kasih.
Terima kasih Pak Sarwono. Ini ada pertanyaan dari Gota. I'm Judul from Institut Teknologi Bandung. I want to ask. Hello, yeah. I want to ask about Professor Tahar and Professor Sarwono. The simple question is, can we use AI in formal verification and security? I mean, if we can use AI, how far can we trust AI to do that? So in formal verification, I believe that we want the mathematical rigor and everything alongside that. But in AI, the mathematical rigor is maybe not rich or anything. So yeah, I want to hear your opinion on this because it's currently booming and I don't know, it's kind of counter, yeah.
Okay.
Not fit, yeah.
Question. I'll answer from the verification point of view, and I'll let you, Professor Sarwono, answer it from the security point of view. So in both cases, the answer is yes, right? I mean, nowadays, if you want to publish anything, you have to have AI because everybody's doing it. And if you are the only one not doing it, then you will look bad. All right. So now in terms of verification, AI and verification are used in two different directions. One direction is to use AI help verification. So for example, so you have a very complicated system to verify. You have a lots of properties. And then so maybe you're missing some property, right? Then you can use AI to generate properties for you. So for example, I'm checking that the car, for example, can go at a certain speed. And then when there is a car in front, then it brakes. Then when there is a change of lane, then, you have to do a certain jerk and so forth. So AI can help you with some scenarios, okay, through lots of databases. It can also help you to automate the verification. So if your verification is not automated, then through AI, you can also use some machine learning in order to make it automated process. So if you have a human in the loop during the verification, like, you launch the process verification, you get the result, you analyze it, and then so you refine it. That loop, AI can help through learning. So that's one aspect. The other aspect is to verify the AI algorithm itself. So there is, for example, you have a car, and then the car is using AI through, like, the cruise control, right? So there is an AI algorithm that is embedded in the car to do like the cruise control. Now that one needs to be verified as well, right? Because we cannot trust anything you build cannot be 100% trusted. I'm talking about trust in terms of safety and functionality, not security. So then how do we verify that the AI algorithm works correct? This is a much more difficult problem. Why? Because AI is based lots of statistical and stochastic processes. So if I launch basically like on an AI algorithm for one process, it gives me result A. I launch it after 1 minute, it gives me result B. And then A is different from B. Why? Because it is very statistical and then it's very stochastic. And then this creates a big problem in terms of verification because it's not really like always the same thing that you get. So there are people that are looking into that. Like, they are studying how to make the logical neural networks, basically the logic behind the neural networks, to study it, to verify it, to make like, more basically, how to say, more mathematically tangible, and then so we can reason about. but it's a very difficult problem. So for AI and security, so I let
Okay, sorry, I answer in the online another person. Intinya apa tadi pertanyaannya? Oh, oke. Jadi AI ini adalah berkah untuk pihak putih, rambut putih juga. Jadi untuk mempertahankan, tapi hacker juga pakai AI. Nah, lalu manusianya di mana? Nah, manusianya jadi pengendali. Jadi terus terang tadi presentasi saya itu mungkin butuh waktu seminggu lebih untuk menyiapkan kalau tanpa AI. Karena dengan AI itu mereka mencari yang online ya, mencari yang online lalu dari yang lain. Jadi sebenarnya AI itu adalah asisten yang setia, tapi mungkin tanpa perasaan ya, tapi justru itu netral. Jadi ya ini balapan ya antara yang jahat dengan yang baik. Nah artinya ya semua harus memanfaatkan, terutama kita-kita yang ngakunya baik ya, justru itu bertahan. Karena mereka itu mencarinya lebih cepat, kita tidur juga mereka bisa crawling, bisa melihat berita yang baru, yang online ya. Ya mungkin juga nanti, bukan nanti ya, kemungkinan APT yang otomatis dengan AI sudah ada. Yang sederhana adalah menjalankan scanning jaringan, ada yang lemah di mana. Nah, scanning jaringan juga macam-macam kan, cuma melihat port saja atau mencoba masuk, dan karena otomatis dengan AI itu dia masuknya nyobanya itu apa ya, lebih tidak terdeteksi, waktunya ditunda jadi scan sekali terus 2 jam lagi. Kalau manusia kan nggak sabar, dia akan cepat gitu mendeteksi, mencari-cari vulnerability. Nah itu langsung di cut oleh firewall karena ketahuan kan, oh ini ngapain ngetok-ngetok pintu terus, ngetok-ngetok jendela gitu. Jadi bayangkan seperti ada pencuri, dia ini jendelanya lemah enggak, ini enggak, nah, tapi itu kan otomatis di cyber dan itu bisa otomatis. Dan Anda kalau Anda ingin belajar bagaimana menghack dengan AI, itu sudah ada komunitinya. Ada yang terbuka, ada yang tertutup. Dan itu dosen Anda atau saya nggak mengajarkan. Nah, justru itu bisa. Oke, terima kasih.
Thank you. Any other question?
Ini masih ada 20 menit lagi. Kebetulan Pak Tahar kan memang nyari mahasiswa. Nah, itu, bukan untuk S3 yang di sini ya. Silahkan. Yang online juga boleh, yang ini juga. Memang khusus mencari student ya mahasiswa.
No more question? You want?
Perkenalkan saya Ahmad dari TB. Ada pertanyaan. Saya ingin bertanya, terutama khususnya untuk topiknya tuh yang bagian bawah-bawah dari sisi hardware dan firmware. Itu kan yang kurang lebih pasti bakal di tap out bersama chipnya dan segala macam. Saya ingin bertanya mengenai verifikasi dari chip tersebut dan karena ada kemungkinan di mana verifikasi tersebut malah jadi sumber utama baru untuk melakukan sumber masalah security baru gitu. Nah itu tuh agak kontradiksi. Mungkin karena kayak kita kan pengen ngecek verifikasi chipnya tuh benar atau enggak, tapi di satu sisi itu bisa jadi backdoor juga gitu loh untuk nanti ketika pengoperasian dan segala macam kita bisa jadi bisa mengakses chipnya langsung gitu dari sisi hardware ataupun firmware. Itu seperti apa gitu mungkin.
Oke. Testability ada di kuliah apa ya? Belum ada? Wah. Jadi kalau desain chip itu kan mulai dari apa Verilog atau VHDL itu harus dibuat vektor test sehingga coverage yang dites itu semua node, sebanyak mungkin node ya. Jadi ada test vektor namanya. Oke. Nah, jadi di level software, maksudnya di HDL atau Verilog itu dengan test vektor yang udah didesain mencoba semua titik dalam tujuan adalah kalau jadi hardware itu sama nggak fungsinya. Oke. Nah, apakah di dalam nanti di sesudah chip dites yang terang chipnya nggak akan berubah kecuali RAM sama ROM-nya ya. Nah, tapi kan masalahnya testability atau vektor test yang didesain itu didesain untuk fungsional atau termasuk security. Nah, itu topik S3 mungkin tuh ya. Itu terus terang belum banyak dan saya sendiri belum ada yang ke sana. Nah, justru tapi merancang test vektor itu kan di desainer. Nah, kalau bisa makanya desainnya di Indonesia kan. Terus dengan test vektor yang sama sesudah dari chip itu oleh fabrikasi. Nah, kalau fabrikasi di luar, kalau mau disisipkan rangkaian hardware bisa. Makanya kalau bisa foundry-nya itu terpercaya dan di dalam Indonesia. Jadi di tiap langkah itu benar bisa disisipkan Trojan horse probability gitu. Jadi lebih baik memang dilakukan tim-tim yang percaya. Dan di common criteria, sorry nggak ada ya, langkah-langkah itu nggak ada di common criteria, tapi justru PPST-nya itu bisa menyatakan bagaimana. Nah terus terang itu masih manual ya menentukan ST dan PP. Nah, saya belum pernah nyoba membuat person profile dan security target dengan AI, saya belum pernah ya. Tapi saya kira itu mungkin juga bagaimana person profile dan security target yang tahan terhadap apa-apa mungkin ya. Tambah S3 satu lagi tuh. Oke, terima kasih.
Oke, thank you.
Mau dimakan bahasa Inggris?
Please. Apa tadi? Tanyaannya.
So it's about when designing hardware and especially firmware because it's embedded in the chip, usually in ROM, immutable memory. So it's a kind of conflict about, from me because when we doing verification with the chip, it could be a vulnerability to security.
Yes, I mean, okay. So when you talk about security, it means that you want to protect, your firmware from intrusion, right? So now, even the security protocol that you're using for encryption and decryption needs to be verified. So there is an area of research called security verification. All right. So it's a total area of research. It's not my area, but there are people that are working on that. So every time there is a new security protocol, right? Either for hardware security or software security or encryption, decryption, you need to verify it. You need to make sure that it is secure, right? So you go through different scenarios and so forth. Just to give you an idea, you know about Amazon, okay? One of the biggest company today in the world. Amazon, currently, they are hiring anyone who has like 10 years and more experience in formal verification. like really very senior, right? So you finish your PhD, you're a professor, you're working in a company, they're willing to hire you. One of my colleagues is working with them, and then I asked, why is Amazon interested in verification, in formal verification? Because when you think about it, Amazon, they're not building hardware, right? They're not writing software. They're actually salespeople. So you are basically manufacturing something in here in Indonesia. Then there is a platform where you can put your product available. Then I'm in Montreal, in Canada, so I can see it, I can order it. I pay to Amazon, and then Amazon is going to pay the retailer, the factory here, the manufacturer here. And then so there will be a delivery coming to my home. Now, throughout that process, there are lots of security issues. And one of the biggest one is cloning. Cloning means I have a product, basically I'm selling this, right? So I go to Amazon and then I find that there is like a picture, there is a photo, there is a description, there is everything. And then down it's written that this is delivered or produced by company X, right? So I place the order, and then so when Amazon is about to get it from the supplier, instead of company X, it's company Y that is sending the product. And then company Y is collecting the money, right? So they are cloning the original one, and then they are collecting the money from Amazon. Now, once I don't receive the product or I receive the wrong one, then I complain to Amazon and Amazon is reimbursing me. So who is the loser here? Amazon, right? So the other point is Amazon is dealing a lot with money transfers and transactions. And then these need to be secured. So I put my credit card. So my credit card information has to be secured. Okay. So, and then the same thing with the suppliers. So they have also kind of transactions of payment, I don't know, PayPal or some other means. So all of these protocols for communication, for payment, they have to be secure. So Amazon, they happen to have their own cryptographic protocol. They own them, proprietary. So it's really their secret. And this is how they're making the money, through that protection. So that compared to other platforms, they are more secure, all right? Now, they need people to verify those protocols that they are designing to make sure, they don't have faults. And then if they're using simulation or they're using mathematical reasoning, they cannot. That's why they're looking for people with formal verification skills in order, to cope with this very, very complicated area, which is called the security verification or security formal verification. Prof, you agree?
Yes, of course. So this is a pitfall because the emphasis only for functional, but they forgot the security. So in my book, in my presentation, the smart city era is already end, and the CPS security is now must be emphasized.
Actually, I have a question also which concern both of you. In the design of, for example, smart card, there are EAL 6. It's formal verification.
Yes.
I can imagine working with formal verification for the functionality or the entropy of the random generator, but I cannot imagine how we can make the formal proof for example, anti-tampering. How do we make the kind of formal verification for that,
Okay.
that kind of examples?
So formal verification, per definition, is to use mathematical reasoning, right, in a computer. So it's a computerized mathematical reasoning. So any system, hardware, software, mechanical, bridge, anything like biology, you can think about it. As long as you can have the mathematical description of it, right? then you can use formal verification for verifying and checking the correctness. So that particular protocol in a smart card, so it somewhere it's modeled mathematically.
We are not talking about the protocol, but in this case, for example, the physical property of the material.
Yes.
So
okay.
That
so
kind of modeling.
Now again, the physical properties of materials, they're also modeled mathematically.
Yeah.
I mean, if you open a paper today of anybody working in physics or in mechanical engineering or civil engineering, you open the paper, you find lots of mathematical equations, right? Lots of math. As soon as there is math, then we can use formal methods. The only problem is that to use formal methods, you need a tool, software tool, right? And that software tool has to have the libraries to be able, to model what the mathematics that you need. So, so theoretically, it is possible. Practically, you need to go deep into the math behind it. I mean, to describe these physical effects. Like one of my students, she's working on formalizing partial differential equations. Why? Because she wants to deal with thermal behavior, right? So when there is something called the heat equation. So when you have, for example, an airplane that is going at a high speed, then there is a thermal effect. So it's a kind of physical behavior, right? So that physical behavior, people in physics, they describe it with partial differential equations. Now, if I'm capable to have a library within my tool that can handle different partial differential equations, then I can use formal methods.
Okay, thank you.
So it takes PhD thesis to do that.
Okay, thank you.
Yes, but we can deep dive to common criteria and ARL specification. So most of people believe that you can get the assurance of certain EAL 5, but forgot the assumption. So we must give awareness to the stakeholder, the maker and the people and the government that every person profile and every security target, for example, for the e-passport, Indonesian passport, it's embedded the assumption. So the assumption, the people who run the device, the reader, and also the passport, the environment. I think there is a lot of necessity for awareness and education. Awareness for the layman and education for the engineer that every device, every OT or IoT have a functional side and security side. Then in the future, more our life, it will be dipengaruhi or embedded in the CPS, embedded in the CPS. So the simple example, I use smartwatch for my Strava and for my sleep time, quality, and also stress. You can track my stress. Is it any assurance that my data pribadi, personal information, it not mining by someone or some institution? It cannot. So maybe we can take a lesson from the narcotic cartel in South America. They won't use smartphone. They only use the simple handphone. Not the smartphone, but only for talking voice. Yes.
I just want to add to the issue of assumption. When you're doing phone verification, you're doing mathematical reasoning. So if you want to verify, for example, for all V speeds, the car is going basically to adhere to when it reaches a certain threshold, then it should brake. Now, mathematically, for all V, and then V is a real number, it can go from minus infinity to plus infinity, right? So first of all, there is no negative speed. So you have to make an assumption saying that for all V greater than 0. And also the car will not go like, 300 kilometers per hour, right? So you say, okay, for all V from 0 to 100 and 150. So you need to put assumptions so that, it adheres to the reality, right? And then this is important, to be kept in mind. About the phones, in Gaza, so Hamas, then when Hamas and the other, Palestinian, fighters, so they are using really like cable phones. So not even like, these old phones. So they have like in the tunnels, they have a phone and there is a cable. Really the oldest technology since like 100 years when the phone, was done, just to be basically on the safe side. About your watch, if it is an Apple Watch, then be sure 100% that Apple, they have access. Yes, 100%. Anything you use from Apple, before you install the application, before you set it up, there is lots of text and you have to say, I agree, right? The minute you agree, they have access to that data. So Apple, they have access to all kinds of Apple products at all times, right? So your laptop, your phone, I don't know about Samsung, but I know for sure, for Apple. They say also they do it for your own security in the sense that if I lose my phone, then I will be able to get in touch with Apple. There is my find, and then, they can trace it. It happened to me to lose my phone in Kuala Lumpur 3 weeks ago. And then, alhamdulillah, through my find my phone, I was able to trace where it is. And then it's the first time I lose the phone, so I didn't know about that. And then so I was capable, I logged into my iCloud basically account. And then so I was capable to see where the phone is. Okay, so, and then it gives you a circle with like, part of the city where the phone is. And then when the phone is moving, you can see it moving. So that's fine. Then afterwards, so I can send a message to my phone. So, and then it tells me, okay, what message would it write? So I wrote a message, please, if you find my phone, call me at this number. So it was my wife's number. And then so from time to time, you can ring the phone. So you can send a sound, so play a sound. So the guy who had my phone, so from time to time, there is a sound. He looks, and then it's written a message, please, if you find my phone, call this number. And then I say, alhamdulillah, because the guy at some point, he called my wife. And then he said, so I have the phone, and then I'm at that particular hotel. And then I was capable to know where it is because on the map it was saying it is in that particular location. I looked at Google Maps and it's a hotel. So where I lost my phone, it was like a shopping mall. And then, so I went to security and then, so they looked at the camera and then they called me. They said was one Chinese guy. He was like, coming from one direction. I forgot the phone on a bench. So he passed by, he seen the phone, he came back, he sit beside the phone, he took the phone, put it in his pocket, and then he left. Right? So then it's an old Chinese guy. So he didn't have the reflex to take it to security. Maybe he thought he can use it, but iPhone is blocked. So he cannot use it unless you enter the number, the code. So maybe he got scared. I don't know. But thanks to Apple having access to my phone at all time, I was capable to retrieve it. But you know, they have everything about me. So same thing with Google. If you have Gmail, if you use Google Map or Google Search, I mean, we are talking about now, I don't know, iPhone, and then after 5 minutes, you see like an ad about iPhone, right? And then the ad will be in Bahasa, Indonesia, basically, even though we're talking English now. So they're hearing us. In iPhone, there is Siri, and Siri is on at all time. Yes, always. Always. Siri is listening to you. So, I mean, you have to be careful. I mean, don't put the phone with you. Yeah. I mean, because there are also signals and other things. We are living in this reality. I mentioned about Tesla car. So one of my daughters, she has a Tesla. So I really know when you buy a Tesla, you sign an agreement. I mean, you sign that you agree that Tesla, they have all the information about the car. So they know where you are. They know what speed. You know what city. They know where you stop. You know where you park. You know even like what you talk. You know what you listen in the radio. You know what the Netflix you put. What game you played. Everything. They say, of course, it's for your own security because you can use the app. You can trace your car. You can know where it is. But there is no privacy anymore. Absolutely. And you know you agree. If you don't agree, then you don't buy the Tesla. Then have to buy the Toyota or whatever.
Okay. Okay. It is very interesting the discussion, and I believe that there are many more questions, but I'm afraid the time is up. So yeah. Uh, I think we can if you agree we can we can distribute your email, for example, so they can ask you by email. Okay. Okay. Mm. Okay. 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 So very much thank you for both of the lectures, and also very much thank you for all of the attendee online and in this room. And I think we conclude this this course, general course. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Yes, yes. Jadi, ya, ini sudah materi yang kalau